Today I'm going through the Unit 11 review to get you prepared for your test on Monday. Number 1 says a polyhedron has 10 vertices and 7 faces. How many edges does the polyhedron have? This is based on Euler's formula, which is on your formula sheet. I grabbed the formula sheet. Right here's Euler's formula. F plus V equals E plus 2. F plus V equals E plus 2. So we're going to go ahead and substitute in the information that we've been given. We have F is 7, V is 10, and we're solving for E. 17 equals E plus 2. We solve and we end up with E is 15. Question 2. Surface area of a sphere is given. We're looking for the radius and then the volume. So again, we have surface area. Looking at our formula sheet, surface area of a sphere is 4 pi r squared. We're going to set that equal to 196 pi. I'm dividing by 4 pi to find the radius. I have r squared equals 49. Finally, we can take the square root and we end up with r is 7. But we're not done. They want us to find the volume. So again, if you need to, look at your formula sheet. Our volume formula is 4/3 pi r cubed. So that would be 4/3 pi 7 cubed. Just showing you what I plugged into my calculator. When I take it to the nearest decimal, I get 1436.8, and that would be centimeters cubed. Number 3, I'm looking for the slant height. So the slant height you can visually see, so that means I'm going to go and use Pythagorean's theorem. I'm looking for the slant height. I have this is 5. The distance from the middle here is 4.5. We're going to set up Pythagorean's theorem. Again, plugging that into my calculator and then finally taking the square root. And it says nearest tenth, so 6.7. Moving on to question 4, it wants us to find the surface area. So if we go take a look at our formula for surface area of a cone, it is pi RL plus pi r squared. The nice thing is we have all the information we need. We've got 8 for the radius, 23 for the slant height. Again, 8 for the radius over here. This one says leave it in terms of pi. So 8 times 23 plus 8 squared gives me 248 pi. Number 5, it says the ratio of the two cylinders. We're looking for several different ratios. So I'm going to set up the 3 columns. I have the similarity ratio is 18/15. When I reduce that, I get 6/5. To get from here to here, if you remember, that's an exponent of 2. So 6 squared and 5 squared, 36/25. To get from here to here, I would have an exponent of 3. So we're taking 6 cubed over 5 cubed, 216/125. Number 6, we're looking for the volume of the composite. So that means both of them together. And I'm doing volume, so that is cone plus the cylinder. So my volume of a cone is 1/3 pi r squared times the height. The volume of the cylinder is pi r squared times the height. Let's go ahead and plug in for the cylinder. I see my radius is 3, my height is 12. Up here I have a radius of 3 as well, but what I don't have is that height. So I need to go find that height in here. So my hypotenuse is 5, my radius is 3, I'm looking for h. You might remember this is the most common Pythagorean triple. If you don't, we're going to set up h squared plus 3 squared equals 5 squared. When you solve that, you eventually get h is 16, so h is 4. So let's plug that in here. So I see 1/3 times 3 squared times 4. So here we have a 12 pi. Let's plug in the rest. Well, 3 squared is 9. 9 times 12 is 108. Finally, we add them together, 125. Okay, question number 7. We have a triangular prism. That means my base is a triangle. So anytime it refers to big B, we're talking about the triangle. So let's actually go ahead and pull that triangle out. I see 12 and 9. Again, I'm going to go label this to be x, and I'm going to use Pythagorean's theorem to solve. And we end up with 15. So first thing they want is lateral area. If you look at your formula, it's perimeter times height. Again, this P is talking about the perimeter of this triangle. So we have 15 plus 12 plus 9 gives me 36 for the perimeter, and the height of the prism is the distance that connects the bases, which in this case is 18. Next, I want the total surface area. So if you look at that, that is the lateral area, which we just got, which is 648 plus 2 big B. Again, those bases are this triangle. So I have 2 times 1/2 times 12 times 9. 648, those will cancel out, the half and the 2. 12 times 9 is 108. And finally I add them together and we get 756 centimeters squared. Number 8, we're just looking for the lateral area. I'll probably take you one step further just to be safe. So the lateral area here is perimeter times height. Notice this is a pentagonal prism, so I'm talking about the perimeter of this. So that would be 5 times 6.2. The height again connects those two pentagons, which is 20.5. .5 centimeters squared. And if I have time at the end, I'll come back and do the whole thing. Next one, they give us the volume of the cylinder, so let's write down that volume formula. Volume equals pi r squared times h. We're going to substitute in that volume. And we are asked to find the radius. Notice you have a height of 36. So we're going to divide by both the 36 and the pi. Those pi's cancel out. When I do that division, I get 272.25. We're going to go ahead and take the square root, and finally we get a radius of 16.5. Okay, moving on. Next one, we are looking for the surface area of the pyramid. So we've got 1/2 PL plus big B. Again, P and L refer to the hexagon in this case. So the perimeter of the hexagon would be 6 times 6. I don't have that slant height, so we're going to have to go find that. So we've got 11, 6. Again, we're going to go use Pythagorean's theorem. And it says to the nearest tenth, we get 12.5. And now I'm looking for the area of the base. So that's the area of that hexagon, which is this guy in here. There are 6 triangles, so that's 6 1/2. That base of the triangle is 6. And finally I have to go find this height here. Again, if we need to, let's pull that triangle out. This is actually a 30, 60, 90. So to get from the short leg to the long leg, we multiply by radical 3. And then finally, we're going to plug all of that into our calculator. I'm going to hit pause for just a second. Alright, typing all that in, I end up with 318.5 centimeters squared. Next question, we are looking for the Again, they start talking about similarity ratios, so let's go set up those columns. We've got 3 over 5. We're talking volume, so to get from here to here, we are raising everything to the third power. That would be 27 over 125. It says the volume of the larger is 120, and we're looking for the volume of the smaller. So we're going to set up our proportion, cross multiply, and when I solve, I end up with 25.9. Number 12, we're looking for the volume of the pyramid. So that is 1/3 big B times H. In this case, they actually tell me what that base area is, and I have a height of 6,000. So pick up your calculator and plug that in. Okay, I plugged it all in. I ended up with 29,500,000, and that is feet cubed. Next, we're looking for the volume of the composite. So in this case, I see half of the cylinder plus that rectangular prism. So I have 1/2 pi r squared times h, big B times h. Let's go after the base volume first, or the base area. So that base area is down in here. That would be 9 times 10, which is 90. My height is 11. Back here, I have a radius of 5. The height, this one's tricky. Again, it connects the two bases, which in this case are the two circles. That height is here, which corresponds with the 9 down here. Let's plug that in our calculator. 353.4 plus the 990, 1343.4 meters cubed. 14. How much paper is needed to make the label of the soup can? So that means we're talking surface area, but specifically we're just talking around that lateral area because we don't have to cover the bases. So that is 2 pi RH. I've got 2 pi. My radius is half the diameter, and I've been given my height. I plug that in. I got 209.4 centimeters squared. Next, they want to know surface area that contains 3 tennis balls. So we've got surface area is 2 pi r squared plus 2 pi r h. So a little bit of digging here. The diameter is 2.7, so when I cut that in half, I get 1.35. And that means actually each one of these are 2.7. So 2.7 times 3 actually gives me a 8.1. So plugging in, I have 1.35 for my radius. Again, 1.35 for my radius. In this case, that height is 8.1. And again, it says round it to the nearest tenth. I'm going to pick up my calculator, plug that whole thing in. Okay, plugging in, I ended up with 80.2 inches squared. Next one, I'm looking for the surface area and volume of the sphere. So my surface area formula is 4 pi r squared. It says leave it in terms of pi. I get 1296 centimeters squared. I'm looking for volume. That's 4/3 pi r cubed. Again, let's type that in. And 7776 centimeters cubed. Alright, let's go up to 17. And actually, I only have about 30 seconds, so let's go take a look at 19, and then I'll go do a few more in the next one. So I'm looking for the net. So I'm going to start with that pyramid, and then if you can imagine, I'm unfolding all of those, and each one of those are triangles. Let's go take a look at the cylinder. If you can imagine, here's that label. I need to have a top, I need to have a bottom. And quickly squeezing